Star colors.
Our closest star, the Sun, is, of course, a miasma of incandescent plasma, superheated gas shining out into our solar system and beyond. If an extraterrestrial being looked up at their night sky and spotted our star, they'd see a little white speck. But Trace, you might be thinking, the Sun, it's sometimes yellow or orange or red. And this is true, lovely viewer. The Sun can appear to be those colors, but that's mainly an illusion due to our atmosphere. Astronauts see the Sun as a bright white source of our heat and light. When you look up at the night sky, it's hard to miss all those white specks of starlight. But if you look closer, you'll notice that not all the stars are white. Some are red, some are orange, yellow, and even blue. Because of Orion's position in the night sky, it's one of the most loved winter constellations, although it can be visible early in the morning at other times of year too. Regardless, the next time you look at the Hunter, look closely at the two brightest stars. And you'll notice the top left one, his right shoulder, that's red. That's Betelgeuse, a dying red giant star. It's cooler than our Sun, which means it burns redder. Red giants are stars that are nearing the ends of their lives. At that point, they start to expand and cool off. Betelgeuse varies between 500 and 900 times larger than our star. If it were sitting where our Sun is now, we'd be inside of its surface. But tucking back out to all of Orion, shift to the bottom right side of the constellation, Orion's left foot, that's Rigel. And if you look really closely, you'll notice it's blue. Rigel is a blue supergiant star and one of the brightest in the night sky. It's 70 times larger in diameter and 40,000 times brighter and twice as hot as our own Sun. If we were orbiting Rigel at the same distance as we do our Sun, we would burn up. To have comfortable temperatures like we do now, we'd have to be 5 times further away from Rigel than Pluto is from the Sun now. That is so far. Star colors aren't arbitrary. The color of a star has to do with what it's burning and its surface temperature. Cooler stars are redder, hotter stars are bluer. And this is the opposite of how your faucets work at home because fire. Instead, think about the flame of a Bunsen burner in science class. Blue flames are the hottest, while the red flames are cooler. Our white Sun, for example, shines at about 6,000 Kelvin, but red Betelgeuse is a cool 3,000 Kelvin, and blue Rigel is a spicy 11,000 Kelvin. The closer you look at the sky, the more colors you're going to see. Look for Spica, Vega, Alpheratz, and Bellatrix for the blue stars, and remember that means they're hotter. Then look for Merak, Antares, Aldebaran, and Arcturus for spectacular red stars, and remember, those are cooler. Stars are incredible things, and there are many reasons to be captivated by them other than their shine. Just like living things, stars are born, they age, they have complex lives, and eventually they die. But throughout their lives, they are all varied and unique. Colors are one of many characteristics astronomers can use to learn more about these incredible, massive balls of fusion. And now you have one more tool in your astronomical tool belt while you keep looking up.